Bye.
start and watch share.
It's on.
Video We're good to start? Good. Welcome everyone. This is the second anniversary of our meetup, started in January 2016, the second year. So out of this 24 months, we missed only 3 months because of the rain things. I just told earlier, we had like 81 external guests to join our meetup, but unfortunately, we have 10% have joined. But it's fine, still okay. It's called recorded live anyway. You can watch it online or you can see the video on our YouTube channel a bit later. I want to introduce you to Karthik. Karthik Dharman is part of our CTO team, Chief Technology Officer team. He's a DevOps engineer, works on all the big stacks. So he's speaking on about Kubernetes. He had his first talk on November 18th. November 19th, sorry. That's the first talk, but you'll do a quick introduction again for the meeting. Then we'll start up with the next part with the today. Right? Thanks very much, Karthik. So I will please make you a presenter. Yeah. Yeah. Go ahead now. Oh, good. Can you fix this audio from here? I'm going to start present. I'm sorry. Yes. Go ahead.
So yeah, I think we can get started. My name is Karthik Dharman, and thank you, Balaji, for introducing me. And thank you for joining the session. We had an initial session like when Balaji spoke to me about this Kubernetes session. We had a thought like we should do it in multiple sessions because covering everything in a single session is very difficult. Even now, covering it in a multiple sessions, very difficult to deep dive into each and every feature that Kubernetes offers, because the amount of features that Kubernetes offers is very high, and it is across platforms which are in bare metal infrastructure or any other cloud service provider that you're working with. So we thought like we'll have multiple sessions. So the first session, as Balaji told, we had it on November 19th. So today is the second session that we are now targeting. So thank you for joining again. I'll just quickly get started. Before even moving to the demo, I'll just quickly go through the architecture and the simple introduction to each of the components that we are using in Kubernetes.
Want your face to be visible in the video? You have to go look more to
Yes.
I'm trying to move the first table, but
Why the issue? Thank you.
Yeah, that's good.
So this is the architecture actually Kubernetes uses. So as I told you, like initially Kubernetes offered only single master architecture, wherein if the master goes down, one of the node picks up as a master. The scheduler does that job, and it is running properly. So the main reason for most of the organizations moving to Kubernetes is that it is self-healing, which is very important. Is zero or very minimal. So that's the main reason everybody started adopting Kubernetes, and gradually like the community got increased, and they started developing a lot of features, and that were consumed by each other, and the improvisations happened. So this is the multi-master architecture. If you could see, there is a master node and the worker nodes. Master, you can have any number of masters. If you're having 3 masters, then if one of the master goes down, the other one acts as the master. So the second one goes down, third one acts, and meanwhile, when the third one is up, the other 2 masters which were off will come back online because it's self-healing, right? So that's one of the powerful features that Kubernetes offers. So that's the main reason, as I told you, like preferred Kubernetes. So what does that have in the master node and the worker nodes? that makes it so powerful. The main components that Kubernetes uses. So the components that it uses is in the master node, it is using an API server. There's a controller manager which has two different controllers again. One is Kube controller and the cloud controller, and there's a scheduler which schedules everything with the help of its architecture. And etcd is the database where all the cluster info is stored. And when it comes to worker node, the main components are kubelet, kubeproxy, and supervisory and the containers. So the master components API server is the main component of Kubernetes. It has all the features embedded in the API. And from 1.6 onwards, they introduced another feature called RBAC, role-based access policy, access control system for the security. So there are like a lot of features which were embedded into the API. So that's how they start improvising Kubernetes. Before that, it was on ABAC, which was a little tedious when we were giving access to other team members who are using the cluster itself. Say, for example, the development team or the testing team who are trying to use the cluster. So a lot many features were incorporated. The latest release being 1.9.2, which was released like 14 hours ago. And there are a lot of features that you can explore. Having said that, like I'll just quickly walk through all the components. API server, it has all the components. And coming to controller manager, it has two different controllers. One is the Kube controller and one is the cloud controller. So the Kube controller, if you could see, it has the node controller, replication controller, and all those things. The node controller is mainly responsible for maintaining the nodes, and the replication controller, it creates the pods in turn. The controller which takes care of all the pods that are being created. And then there are a couple of other controllers that you can make use of. Similarly, there's a cloud controller, which has again different level of controllers. The volume that you are attaching, there's a volume controller that takes care of it. There's a token and service controller that is being taken care of. Similarly, like we have a number of controllers internally which takes care of each and every component that we are seeing here. I'll deep dive into each of the component once I finish the introduction. So moving ahead, when you come to the worker node, this scheduler plays a main role because scheduler schedules all the nodes, the pods, and any service that you're consuming Kubernetes is taken care by this scheduler. It schedules all the pods and it takes care of all the the resources management and where to schedule a pod, how to schedule it. All those things are taken care by this scheduler. So coming to worker nodes, you can have a number of worker nodes. And here, if you could see, the main components are kubelet and kubeproxy. Kubelet, which does the major chunk of what Kubernetes offers, Kubernetes node offers. So it does everything like creating the pods, scheduling them, assigning volumes to them. Anything that a pod does or anything that happens in the background that you are doing is taken care by this kubelet. Now, kubeproxy, again, as the name indicates, kubeproxy is nothing but port forwarding or taking care of all your networking activities that the Kubernetes offers. So the containers, again, it supports Docker and RKT containers. RKT is still in experimental phase, and Docker, most of them have adopted it. So Docker is the main container technology that is embedded into Kubernetes. Now there's another component called supervisor D, which is responsible for maintaining all the node components. Say, for example, if kubelet is down, the node itself is not going to work, so the entire cluster is being messed up. So that's the main role of supervisor D. It takes care of maintaining kubelet, the container, and the kubeproxy. So these are the main components of Kubernetes. So when it comes to the architecture, how it works is like there's a client called kubectl through which you can access the API. You'll access the API, and from there it will contact the the worker nodes through kubelet or any other service that you're looking for, and then it'll fetch the information and it is rendered in the UI. So the main working concept of this kubectl client is that it's mostly through CLI, because in the UI it's very easy to just go click something and get the job done, but some people prefer CLI. Mostly all the architecture, all the Kubernetes functions that are being, or any other services that are performed, are configured to kubectl. So kubectl is the client through which you can access Kubernetes API, and is the main component that you'll be using it to create anything in the Kubernetes architecture that you have configured. So any questions on the components or the architecture that you want me to explain?
What is the role of API server here?
So it has all the API components that you are consuming. Say, for example, you want to consume the RBAC component. It has a beta 1 component. It has an alpha 1 component. Each has different features, so you can consume all those things. So that's the main role of API server. So everything is stored in this etcd database. So all the cluster information is stored here. If you want to upgrade or move on to any other thing, then you'll have to take care of this etcd, because all the info is here. You'll have to take a backup and be very careful about it. So there's one of the main features that Kubernetes offers, which is cluster auto scaling. How it works is like, initially when the load increases, here one of the pods get increased, and similarly for any service that you're using, the pods keep on get increasing. But at a point, you'll reach a point where the node will not have enough capacity to hold the pod. At that point in time, the cluster autoscaler will push the pod to any other node. Say, for example, all the 3 nodes that you have configured is of full use, then it will automatically spin up a new node, use it, and when the load reduces, it will automatically spin down the new node and the pods that were created. So the pod increase, that is called horizontal pod autoscaling, and the cluster autoscaling is the creation of new nodes to accommodate the pods which don't have enough resources in the nodes that we have already used. So that's how cluster autoscaler and HPA works. So that is one of the powerful features that Kubernetes offers. So moving on, Kubernetes UI, it has all the features listed on the left side, and when you click on each of the workload, you can find what is happening, what are all there, and all those things. I'll just quickly go through it as well. So prior to the session itself, I just made my Minikube ready. For example, if I want to leverage Kubernetes in my local machine, I'll have to use Minikube or any other utility that is available. If you're using bare metal, you can go and install. If you're using AWS, you can use a utility called KOps. If you're using Google Cloud, you can use a utility called G Cloud. There are a lot of utilities for each cloud service provider or the infrastructure that you're using. So that's how it works. And here, for me, it's Minikube in my local machine. And we as a team, we are using AWS. KOps is a wonderful utility that we are using. It's easy to upgrade, maintain the system, and the cluster itself, it behaves in a way that you can easily incorporate any feature, any new feature, or you can use the maximum extent of the feature that you're using. So quickly moving ahead, I just started it, and the dashboard is here. So this is how the dashboard looks like. So
video is not coming through, so this is fine. Cool.
So this is how the UI looks like. The logo itself appears on the top. Since it's Minikube, I'm not able to show the components that you are looking for. If you just have a URL, just do API over here. Just leave it with the port number. You'll have the APIs listed. You can consume, and you can see what are all the APIs that are being used. So that's the thing about API. And so the left side, it has all the workloads and the overview listed here to each and everything. Cluster. So cluster is a group of the nodes that we are having, all the master nodes and worker nodes. So namespace are very important, because this is how you differentiate any any shared cluster that you're using. Say, for example, you want to use a single cluster across multiple teams that you're supporting. Say, for example, you have like 10 different teams that you're supporting. Then what you can do is like you can create a namespace for each of the teams so that all your workloads go and get stored there. If you see there are namespaces listed here. There's a drop down. I have like 4 different namespaces. Default, kube public, kube system, and the other one that I created is testing. So default, kube public, and kube system, these are the default namespaces that get created when you create the cluster. So all the pods that you create initially without namespaces called namespace. Next one is the kube public. All the Kubernetes service related services or pods or whatever it is. If you just go to pods, you can find something. If you go to services, you can find something, or you can go to secrets and find something. There's a secret called default token created for kube public. Similarly, the kube system, all the DNS, the kube DNS that you create or any other Kubernetes component that is specific to the system will be created here. This kube system will be, publicly readable to all the users that are accessing the cluster. So the testing namespace is nothing but the namespace that I created. So unfortunately, like any other technique or tool that you're using, it's difficult to create a namespace from here. That's where this kubectl comes into place. The client that I told to create a kubectl namespace, you'll have to just create it via the kubectl. So let's create a namespace called demo. If you see the namespace demo is created. So I'll just quickly list the namespaces. You could see along with the default kube public kube system and testing that we created, there's one more namespace called demo created. I think that's
command plus.
Better now. Okay. So I just easily created a namespace here, but it's difficult to do it via UI. Few functionalities you cannot do it via UI. If I quickly go and refresh the page, I can find that over here. Refresh the page, and if you could see, I have created an empty namespace called demo. I have a secret created for every namespace that you create. There's a default secret that is created, a default token to access that namespace. So similarly, all the functions can be done through kubectl. UI, there are only specific functions that you can, features that you can use. So because even dashboard UI that I'm showing is another feature that is being developed. So there are a lot of feature requests that are put in, but the community, though they are actively working on other features, they are not concentrating on the UI. But there is a substantial amount of improvement that was done on the dashboard. So this is how the dashboard looks like. So I created a namespace. So namespace, it can be, as I told you, if you're using a shared cluster, you can use that. You can use this functionality. What is namespace in turn? It's nothing but you're trying to create a virtual cluster within a physical cluster that you're using. So this itself, the entire Kubernetes cluster is a physical cluster that I'm using in my local machine. These demo and testing are like, they act like a virtual cluster. So I have like a demo team and a testing team. So these are using the same cluster, providing varied range of functionalities, sharing the resources. Everything shares this particular node. I have only one node because I have it in a local machine. You can have like 3 masters or any number of masters, any number of worker nodes that you want to leverage. So based on the load that your service is going to consume or your application is going to consume. So that's about the namespaces. So moving on, nodes, as I told you, node is nothing but a worker node. It was previously called minion. Prior to calling it a worker node, it was called as minion. Earlier they called it as master and minion. Now they call it as master and worker nodes. So a node is having all the it's nothing but a physical server in itself, be it a EC2 server that AWS offers, or a physical server in case of bare metal, or anything in GCP or Azure, whichever you're using. So these are like the nodes. When you click on the node, you can find all the details specific to a node, the resources that are allocated, and the pods that are made available in this particular node. you could see all the pods that I've created are made available in this particular node because I have only one node. So when you have like 3 or 4 different worker nodes, each pod gets assigned to a different number of nodes. That job is done by the scheduler, as I told you. Look at the nodes, looks the resource management. It tries to push the node to the pod to a different node. So that's how it works. And there are no events because I haven't created anything. So if there are any events, that will be displayed over here. And all the resources prior to 1.6.3 dashboard version, this allocated resources section wasn't there. So it was like very difficult. You'll have to go and check how many parts are allocated to a node. You'll have to do a manual calculation, all those things. Now this dashboard does that for you. So like this, there are like many number of features that are being worked on for the UI as well. So it's not so mature like the features via kubectl, but it has sufficient amount of features that you can use for a production grade application that you are trying to come up with. The info is available here. If you could see the kubelet version, it's 1.8.0 because the minikube that I'm using is on 1.8.0. That's why it's showing this particular version. When you upgrade to 1.9.2 or 1.9 to consume all the features, so you'll have that kubelet version point to that particular version that you're using. So 1.9, again, it offers a lot of features. Even 1.8, it was having like a number of features that you can consume for the application, whatever configuration that you're trying to use. So moving on, as I told you in the previous session, persistent volume and persistent volume claims. This is one of the important concept that important feature that Kubernetes offers. So persistent volume and persistent volume claims. Volume and volume claims, as the name suggests, it is nothing but the storage feature that Kubernetes offers. So persistent volume, what it does is like you can assign storage to each of the pods that you're using. So that can be rendered via the pod YAML that you're using. So what happens is like you can define the volumes and you can claim it using the PVC. You'll have to create a PVC and a persistent volume. So once you create those, it'll be made available over here, the volume. That volume in turn can be claimed by this persistent volume claim in the namespace that you're using. So any namespace that you want to leverage that functionality, you can use it. So that's how this persistent volume and persistent volume claims. Roles, I haven't created any roles, but the role-based access policy, as I told you, it's a varied concept. Like there are a lot of features, RBAC policies that you can use. I'll quickly go through them. So RBAC authorization, it's nothing but like you create roles and role bindings. So you create roles specific to this particular cluster. So what you'll end up doing is like you'll go to this when you go to this roles, it'll list all the roles that you have created. So by default, it creates the cluster level roles for read access to the. And there are many roles that you can come up with. Say for example, take a use case scenario like I want to have read access to this particular testing namespace and give it to the testing team. And I'll create a namespace read access for that particular role. I'll create a role for that, and then I'll create a role binding to specific user. Say for example, the testing team has a generic account. I'll create a role binding for that particular account, and I'll map it to that particular role. So that particular role, I'll assign it like I'll give the resources that the team will have to use or consume. So I'll provide that in the role section. I'll create that role and I'll bind the user to that particular role via role binding. That's how this RBAC authorization works. So moving on, storage classes, as I told you, it is like profiles in any other system. I don't think so most of the people are using this feature as yet. We are also not using it, so I'll just quickly to the workloads. So workloads is the main place where all your pods and deployments, replication controllers, replica sets, everything get viewed on. So coming to the daemon sets. So daemon set is nothing but a feature that Kubernetes offers where you want to have a pod in each of the nodes. Say, for example, you're trying to collect logs from each of the nodes. So what you can do is like you can have a fluentd type of pod created in each of the nodes. When you define that as a daemon set, it gets created by default in all the nodes. You don't have to specify you have to go to this particular node and create, or that particular node and create. So what you'll have to do is like you'll just create a daemon set which deploys the fluentd into the container. So that's what daemon set offers. When you want to have a pod in each of the nodes, if you have come up with such a scenario, then you'll definitely have to go with daemon sets. Now coming to deployments. So deployments and replication controllers, they both offer the same feature. So deployments and replication controllers, what they do is like they create the pods for us. You can either have a deployment YAML file or a replication controller YAML file. The main difference between the deployment YAML file and the replication controller YAML file is that when you have to go to deployment is that when you want to maintain the history of deployments that you have done. So when you want to maintain a history of those, you'll have to go with deployments. These add-ons or any other master component YAML files that were created prior to 1.6 or 1.5, it was on replication controllers. Now it started, moving on to the deployment type because they see deployment is the future feature that deployment is a feature that for future use. So deployments, as I told you, you can create those deployments if you want to maintain the history, but deployments and replication controllers, they both do the same function, but with the only additional feature with deployments is that you have the history maintained. So you can roll back or roll out any number of versions that you had earlier. So that's the main feature of deployment. So jobs, you can have cron jobs if you want, as the name suggests. If you want to run a specific cron job on specific number of pods or any other functionality that you want to leverage, you can have those configured. And pods, when you come to pods are the main feature, main containers that are being used. So what is a pod is like it's a collection of containers. Like you can have like pod created for each service that you're doing. So all of these pods are created deployment file or a replication controller file to have a better way of coordinating. Otherwise, you can create a pod from a direct scenario also. So what we do is like we always create it through deployment or replication controllers. So moving on quickly, like replica sets, it does the same functionality as replication controllers. So deployments creates replica sets. Replica set in turn creates the pods for us. You could see the deployments. I have a deployment called front end. So when I go to replica set, a front end replica set is created. For that particular front end replica set, I have 3 different pods. Similarly, you can have any number of pods created. Say, for example, I'll just quickly go here. If you see the replicas, there is a section called replicas. I put it as 3. When I put it to 2, I can easily update it. So you could see the number of pods that are being created, it gets terminated. So this is how it functions. Like whatever number of replicas you do, it just creates it automatically. Say for example, if you have 10 different replicas configured in your YAML file, then if one of the pods goes down, it brings up automatically. So that's the self-healing policy that applies to pods also. Moving on to stateful sets, again you can create stateful sets as you want. And ingresses, it offers the ingress service. If you want to access your service from the external world, you can use these ingresses. And services are important because if you could see pods, as I told you, they are mortal, right? Because it goes down, it comes up, you never know, because it is not immortal at all like a node. So if you want to delete a node, you'll have to go manually delete it. unless and otherwise it's not going down. So pods are not like that. It goes, those are modeled. So how can you like access within the namespace or within the cluster itself? So that's where these services come. So how these services work between the pods is that there is a section called labels. So it finds that particular label within the cluster, and when the label matches, it provides that functionality. So configuration and storage, as I told you, persistent volume claims, you can claim the volume that you have created for the cluster. So config maps and secrets, they are nothing but if you want to store configurational data, the environment variables for each environment. Say for example, dev will have different configuration, QA will have different configuration, stage will have different configuration, prod will have different. So what you'll have to do is like config maps and secrets. You can have all those configurations created using config maps and secrets. So the only difference between secrets and config maps is that, as the name indicates, secrets, those are for the information that are confidential. If you want to store password or access keys or secret keys or whatever, whatever the data that you don't want to expose to the external world, those can be configured as secrets. Some non-confidential data, if you want to configure for the cluster, then you can go with the config maps. So these are the components that Kubernetes offers. So what I'll do is like I'll quickly go through a demo application that I've created for you. So
sit down, type.
Yeah. Also, so kubectl get namespace. It just showed the namespaces that I've created. Similarly, if you want to get the nodes that you want to know, can you give it as nodes or just type no? It's going to take it. So this is the only node that I have, as I showed you in the UI. You could see this is the only node. Minikube is the only node that I have it in my cluster. So similarly, there is a feature through which you can see whether your cluster is healthy or not. Just to find the component status, you can just do this. It's going to give the component status. So it says everything is healthy. Say for example, if your cluster is down or it's non-functionable, it's non-accessible, you can just quickly go and check what is wrong. It's going to throw the error message if it is not going to be healthy. One thing that we noticed while implementing this, if your master node is running out of disk space, then your UI is not going to respond at all. Just shows the UI and it's not going to perform any action. So that's one thing that we noticed while implementing this. And similarly, like component status, you have like a number of features that you can leverage using this kubectl client. So now what I'll go is like I'll just quickly go through the deployments that I've created. As I showed you, when you just give this kubectl get deployments, going to throw it from default. If you want something from a kube system or kube public or demo or any other namespace, then you'll have to explicitly mention the namespace. Say for example, I'm just giving demo wherein I don't have any other any pods at all. Similarly, like if I want to yeah. Sure. So kubectl will help you get all the resources that you have it in your cluster. So if you want to create any application or service, then you have to come up with the YAML files. YAML files are the main sources for using this, and there is a kubectl cheat sheet that you can go through, which will be very helpful for you to navigate through kubectl if you're a beginner. So this is the cheat sheet that you can use. It is self-explanatory and it has all the details wherein you can use. So all the commands that you can use, the context, the configuration, everything is being listed here. So this is how you can, go ahead and check all the utilities that kubectl offers. So just gives everything. So pods, as I told you, these are the important features that Kubernetes offers. It has all the capabilities to run your service. So having said that, now I just have the pods. I'll just quickly go through and create a service and launch it. So what I'll do is, like, I have this deployment created already. So I have all these files within the demo folder. Sorry, testing folder. So I have all the files here. Just quickly open one of the files and explain through the components. So this is the API version that I'm using, V1 Beta 2. So V1 Beta 2 is the API version that I'm using. I'm just specifying the kind here because deployment or a replication controller kind to create your pods. So metadata, as the name suggests, you can give the configurational data, name or app or whatever you're going to configure. Similarly, there's a specification section, and this is where you give the matching labels to find your service. The match label here is having an app called guestbook and tire called front end. So the replicas, as I told you, it is having 3 different replicas. If you want to scale them to any number of replicas, you can just go to UI and do that. I'll just quickly go here to the deployment that I created front end. You can just go here and scale it to any number of. It automatically comes up with a pod that is creating. If you could see, there is a pod that is being created. The age is just a second. So it just created another pod for me. Say, for example, if I want to scale down, I'll quickly go there and scale down. So it is that easy to scale up and scale down within Kubernetes. And you cannot go beyond, below 3, because 3 is the default replica that you have set in the YAML file. So moving on, you can scale it via kubectl as well using the auto scale feature. And again, the template has the metadata, as I told you, app and tire. And the container specifications are mentioned here. What is the name of that container? From which image you are going to provide. Say, for example, if you have this image stored in your AWS container registry or any other repository wherein your images are being pushed, you can reference those here. It's going to pull that image and then have the pods ready. And you can have a default resource allocated. Say, for example, if you want to have 100 millicore CPU and 100 MI of memory to this particular pod, it's going to allocate only that much. So the request and limits, there is another section called limits, which is not mentioned, which is not applicable for this particular container because I just took it from one of the samples that we did. But you can have another section like resources called limits, wherein you can limit the amount of resources that this particular pod can use. Say, for example, you're coming up with a pod called frontend hyphen whatever the metadata is going to append, the Kubernetes itself is going to append. So what it does is, like, it's going to have a default limit to that particular pod. You're not going to reach that particular, say, for example, you're creating a HPA and you have a maximum limit. Say, for example, you set it at 90. When that particular pod reaches 90% of this CPU or memory, it's going to spin up another pod, the horizontal pod auto scaling. When that pod is not able to find the resources within nodes, it's going to create a new node. That's called the cluster auto scaling. So these resources get automatically accumulated in the node section here. If you go to node section, you can find the allocated resources over here. You can find the accumulated allocated resources for each, for all the pods in your UI for the node itself. Say, for example, if you have like 10 worker nodes, you can see how many nodes have less resource utilization, how many nodes have high resource utilization. So that's the main reason why we use this particular section, requests and limits. So env is nothing but the environment configuration that you can provide. You can provide the configuration of your config maps or secrets over here. You can have secrets mentioned over here, and then this particular pod which is being created will automatically refer to that particular secret that you have created and the namespace. So ports, as I told you, the container port in which your application needs to run, it's either 80 or 8080 or 8090, whichever container port you want the pod to run. So this is about the file that we are creating. Similarly, there are a lot of varied features that you can leverage from the YAML file itself. So if we quickly go through here, the service, it's going to have the same spec and other configuration details, except for the fact that the kind is alone is service here. So it was deployment there and it is service here. So this service gets created and then you can perform the function. So what I've done is like I've done a front-end deployment. I'll quickly create all the others. So to create that, you'll have to use a command called kubectl create -f and the file name. So front-end service.yaml. Similarly, I'll quickly create the other ones as well. kubectl create -f redis master deployment YAML master service, and I have a Redis slave. And a slave service. So now that I have created everything, I'll quickly go to the UI to check whether they have been created. You could see under different, go to default, because I created everything under default. So it created the deployments and the services. You could see all the services are available here: front-end service, Redis master service, and Redis slave service. Similarly, I created the Redis slave and Redis master deployments. So what it does is like this deployment, as soon as I created it here, it created a replica set over here. This replica set in turn created the pods. So all these pods, as I told, they are mortal. So to leverage the functionality of each pod, what we do is we create the services. Those services are being created here. If you could see, this is one of the important section that you'll have to concentrate. If you want to have a load balancer, then you'll have to change your YAML file accordingly. If you go here, I have it as node port instead of the service is Redis master service. If you go here, or to the Nginx thing that I created, or you can go to the service itself and click on edit to find what it is using. The type that it is using is cluster IP. If you want to have a load balancer type, you can just change this to load balancer, and it is going to create an external endpoint over here. So what it does is like the service creates a external endpoint over here, and then you can access the you can do a Route 53 entry to that particular external endpoint, and you can use the DNS name in the UI. So this is one of the functionality. Like it has 3 different load balancer and cluster IP. So what we do is like we do it, whatever the endpoints that we want to expose to the external users, we do it as load balancers. Others we leave it to cluster IP, because the cluster itself is going to manage through the kube DNS that is being created as part of the cluster creation. So the kube DNS pod gets created, and it's by default made available in kube system. Again, as I told you, Minikube doesn't offer much features. So since it's my local machine, I'm not able to share all those details. DNS is over here. It's going to maintain all the DNS configurations that the cluster uses. And moving on, as I told you, I've created all the services, and so this green icon indicates that either a service or a pod or a deployment is ready and ready to use. But there are a few scenarios where your pod doesn't get scheduled, or it's going to throw out an error that it's not going to find something. Or say for example you have a MongoDB or MySQL connection, that connection, if it is not going to happen, what it is going to do is like this particular deployment, it's going to be in the state what this service offers. It's going to come throw an icon like this, and when you go and see the logs of the pods, you can actually find what is happening. So if you go and find the logs of the pods, either you can do it through UI, again you can do this through kubectl. So to find the logs of the pods, what you'll have to do is like I'll first get the pods, and this particular pod is ready slave. So just quickly go here, copy this kubectl logs, and it's going to throw the log in your UI as well. I mean the CLI as well. So you can find the log and check what is really happening. If it is not going to work, you can find and fix the issue and then deploy it again. So there's another functionality that you'll have to you can use as well. Say for example, if you want to deploy the same thing in the other environment, but you don't have the time to run it or build it through Bitbucket or any other system that you're using through Jenkins, pick it from Bitbucket, build it through Jenkins and deploy it. What you can do is you can always go to pods, list the pods, get the pods through, get the output to a file, and then you can deploy that particular file in a cluster. So it is that easy. You can just do it like get pods. It is like, so when you do a OYAML, it's going to show it here, and if you want to move it to any other file, I can just do that. So it's going to put it in the test YAML. Sorry, it's going to put it in the test YAML. Now that I can deploy this file anywhere, because I don't have a namespace created here. Say for example, if you want to create it in a specific namespace, you will have to go to that particular YAML and go to the metadata and then give the namespace here, and you can change the namespace where you want to, because across the environment you will have different number of namespaces. For dev, you may name it as like testing-dev01, and for the QA you can name it as testing-QA01. So you'll have to change the namespace accordingly, because there's not going to be a testing-dev01 namespace in the other cluster or other environment. So likewise, you can customize your YAML file which suits your configuration and necessity, and then you can use them. So moving on, like I think the service is created. It's still creating. And moving on, I just wanted to touch base on, say for example, if you want to delete something, you can always go here and go to the testing one. So when you want to delete this particular deployment, you cannot go to a pod and delete it, because when you delete this particular pod, it's going to bring up another pod. If you want to delete the entire thing, you'll have to delete the deployment and not the pods. So when you delete the deployment, it's going to in turn delete the replica set and then the pods as well. So what I'll do is like either you can do it from here or you can do it through kubectl, anything you want. So I'll just quickly delete it. It's going to delete everything. So when I go and check the status of the pods, it's getting terminated. It's taking some time, so it's getting terminated until free up the resources. The replica sets, go and find those, getting terminated. It's going to take some time, so deletion happens. Similarly, you can create, delete, or whatever the operation that you want to perform. And moving on, like when it comes to logs, as I told you, you can either view it via UI or through the kubectl utility that I told. But there's a catch here, because when you create the cluster, all your logs get pushed to the master server, the master node. So all your master controller or the API server log or the syslog, everything goes and falls into the where log partition in your master node. So the logs that pods uses, it is being stored only for 1 day. So you'll have to come up with different, any utility that is going to offer, you to pump the log from Kubernetes master and use it and store it. So we are having a utility. We are using a tool called Sumologic. wherein the Fluently pumps the logs and stores it there. And we have like several queries that notifies us that this is wrong, that is wrong, the log is throwing so and so error, there's a warn or error, then it's going to send us a notification through Slack. This is the architecture that we are using. Similarly, you can come up with any log monitoring tool that you're already using, or you can come up with research and find the specific tool that suits your configuration. And this resource the resource management is tedious again, because when you come up with a large cluster, when you're supporting like 10 different applications or a number of applications, this resource management becomes tedious, because uh, if you could go to UI and see it, you cannot get a notification or anything at all. You don't want to go to the UI and find it every time. So you can have a monitoring system for that as well. What we are using is Wavefront. We push everything to the Wavefront cloud and get the info from there. So if there is a disgrace issue or any other resource allocation issue, it's going to throw us a notification, and then we go and correct it. So these are few tweaks that you can perform on top of Kubernetes to make your the cluster stable and more utilizable. And moving on, once all these services are created, the ones that I created is in default, so it's still creating. So there is something called probing technique in Kubernetes. So for the probing, I have an example here. What I'll do is like quickly deploy that. So it created a pod called liveliness. There are two different probing that you can perform. One is liveliness and the other one is readiness. So why you have to perform this probing is that when you have multiple services supporting your application, say for example, you are using the microservices architecture, then you are having like n number of services to support and combine. So what you can do is like to find whether this particular service is up or not, that particular service is ready or not, you can use this probing technique. So liveliness probe is nothing but to check whether your application is ready. Whether it is live or not. So all your deployment is started and all your the deployment is done and the service is up. So that is what liveliness probe is going to indicate. There's a specific time that you can set based on the service that you are deploying. Say for example, some services may come up in 45 seconds, some may take like 3 minutes. Based on that you can define. So but based on the definition, it's going to take that much time to deploy that. So that is something that you'll have to work on as well. Permutation combination that you'll have to perform to find the exact timing that's going to take less time, but it's going to deploy it properly as well. So that is something you'll have to consider as well. So the liveliness probe, as I told you, it's going to create that pod over here. You could see this liveliness probe is going to, if you go to the YAML file and check, as I told you, initially it takes a delay second, and the failure threshold, success threshold, period seconds, timeout seconds, going to check. You can give the command that you want to check your service liveliness or not. So you can have your service, say for example, you have a HTTP execution service, then you can provide that over here. Any other execution that's going to check whether your service is live or not, you can use that over here, and specify the timing accordingly. Timing is very critical here, because based on the timing, it's going to take the actual time for deployment. About liveliness, there is something called readiness probe as well. Readiness is nothing but once your application is live, when the readiness probe is working properly, it means that your service or application is going to be ready for taking up load as much as it can. Say for example, if the load increases, then pod is actually ready to take the load. So when it has reached the maximum capacity, if you have defined HPA, it's going to spin up another pod. So this is how the flow works. So that is the readiness probing technique that you can use. So apart from probing liveliness, persistent volume, persistent volume claims, there are like additional features that you can explore that may be useful for your application or services that you're using, because what we are using is microservices. Maybe if you want to use any other services or application, and the deployment type or configuration that you're using based on the cloud service provider or bare metal infrastructure that you're using, you can always come up with the YAML files customization that is going to help you with the deployment. So moving ahead, as I told you, if you are using AWS and you are going to start your Kubernetes, kickstarted, there is a service that they created, and AWS EKS, that was recently mentioned in the AWS conference, which was conducted in November, I believe, November 25th, I believe. So Fargate, it is for deploying your containers hassle-free, and EKS, Elastic Container Service for Kubernetes. It's going to take every burden of you and create the cluster for you. It's going to take all the load that you're going to do. If you want to create a cluster and maintain, it's going to be tedious. You'll have to maintain, you'll have to make that stabilized so that there is no downtime, or there's no issue occurring for the deployment, I mean the development teams that they are consuming. So what EKS does is that it does the cluster creation and everything for you. All you'll have to do is that go ahead and configure that in the AWS console. So that easy is it is. We explored it once, but we didn't use it. EKS and Fargate. That is something we are trying to see if it is going to minimize a burden. But our thing is stabilized. We are upgrading it frequently. So say for example, if you are in 1.8, or if you want to upgrade to a higher version, so you'll have to perform a cluster edit, which is going to help you with that. So as I told you, like, you'll have to edit the cluster to move on to a specific version. I'm on 1.8. If I want to move on to 1.9, I'll just go to the config file. So config file is another important concept that I forgot to mention. When you install kubectl, it's going to create a directory called .cube. It's going to have the config over there. So this is the config file that we are using, at least for the demo. So to find the current context, so this will throw the current context that I'm using. Minikube, if you are having n number of clusters, say for example, cluster across each environment, you can have everything clubbed to a single config, and then you can switch the context accordingly and work on that particular cluster. It is that easy. So this config needs to be edited. Just go and change the version. Say for example, if you're 1.8, if you want to move to 1.9.2, which was, as I told you, released some 14 hours ago. So if you want to move on to that particular version, just go and do the 1.9.2 change in the cluster, edit the cluster, save it properly, and then come out to a update and a rolling update. Your upgrade is ready. It's going to upgrade it to 1.9 without downtime. So what it will do is, like, first it will pick the one of the master node. It's going to upgrade that to 1.9. Once that is up, it's going to pick the next one, and finally it's going to perform on all the nodes that you have. So this is how the upgrade is going to happen. So there are similarly, like, there are a lot of features that Kubernetes offers, which is like beyond the scope of this demo, because if you want to explain, you can start explaining for 2 days, 3 days, 1 week. So that is the number of features that Kubernetes offers. So as far as this demo is concerned, as I told you, you can create everything as a service, and once your service is ready, unfortunately it's not ready yet. I don't know why it took some time. So once your service is ready, if you have the load balancer, you can hit that load balancer in the UI and access the service, or you can use the internal endpoints that is going to give it to you, and then you can have your application accessed. So this is how you can deploy everything to Kubernetes cluster and make use of it. So if you have any questions, maybe I'll be able to take it and answer. I think it's 7:30 and yeah. Yeah. Yeah.
Because all are microservices,
Yeah.
we'll be getting even 5,000 micro calls.
Yeah. Yeah.
How will it handle?
Yeah, it's going to handle. It's going to handle. going to handle, because we have a database which is having all its services on MySQL and MongoDB as well. So we have like different, I mean, we don't have a specific number of calls as such as you told, but the number of calls is very high. So the microservices is definitely going to handle the cluster.
This would be a manual cluster by us, like that has done AWS ELBs and application network ELBs, the latest ELBs which are coming up, can scale up to millions of requests.
Yeah.
Is it really production ready? Because we are actually.
Yes, it is ready, because that's why we are using Kubernetes, right? It's ready. That's what I told you. It's,
Yeah.
when you have the HP and CA configured, it's definitely going to spin up a pod. If it's not going to have the resources, it's going to spin up the cluster. I mean, the node. Cluster. Yeah, we have done load testing once. We don't have a testing ready for the application that we are supporting. We did a load testing that is available on the internet, and it was successful. We had the cluster auto scaling happening. So
An instance of
Yeah.
service which you're talking about, the proxy, Linux proxy, because
yeah, it's going to handle those requests. Yeah.
Handling microservices. Microservices are in the container phase. Container phase. So if they're container based, well, ELB can totally handle. But what if your like the monolithic application? Typically, it was specifically done for traditional application. So this is more for containerized applications where your application is microservices, and if you can talk to different. What you said is right. We can absolutely scale it up. But if the architecture is totally container based and this is all like like ingress based or load balancer based, so this handles the entire. So
all have the container.
you are reading networking.
Yeah, so the problem.
Read networking has got
a very old like extracted the view.
are you talking about the view company or
yeah, that's the same thing. So that is not able to handle. So we use internal ELBs and then we call them containers. We have like five containers running. Serve and service.
See, this is Kubernetes is nothing but Borg, which is a Google platform. So it is war tested. You don't have to worry about whether you can handle any number of those. Google spins up almost 1 billion containers a day or an hour or whatever the number is. So it's absolutely suited for it. So this is nothing but a fork of Borg. Kubernetes is nothing but a fork. Now, I don't know how your ELB, you're calling your ELB and spinning up so many services. So pretty much Kubernetes can handle whatever ELB is handling, and on top of it, we can handle certain things more. So let's say if something goes down irrevocably. I know ELB also can do it, but I don't know specifically your case what you're doing specifically in ELB. Kubernetes can also.
Any other questions?
What kind of network you use for the nodes, like panel or?
So we use the Route 53 of AWS, their service. We don't use Flannel or any other network that they provide. Flannel, you want to go with the bare metal infrastructure, I think you can go with. So we don't use Flannel.
And Fargate is mostly serverless, right?
Yeah, serverless. Fargate. And I don't think so. I don't know whether it's EKS Fargate or Fargate or EK is one of the services is available only from 2018. I think. From 2018, though they introduced it in the conference in November, it was readily available only from January. Yeah, I think it should be Fargate. Yeah. So these are the new services that were launched by AWS, making us lazy. That's their ultimate motto.
So right now you're using it in production.
Yeah.
Going.
So how many microservices are running on that platform?
So we have two different applications. One of the application has 25 microservices. The other one has 9 microservices. 9. Along with that, we have a RabbitMQ cluster for messaging queue. So that is having like 3. So totally 12, including the RabbitMQ. So 25 plus 12, 37. Apart from the other add-ons that we are using Wavefront, and Heapster pumps it to Wavefront. 2ND pumps to Sumo Logic. So each of them comes as a service. So that in turn has a number of services. Wavefront.
Different.
Yeah.
Prometheus also is there.
Yeah, Prometheus is service. And the cloud service that we are using is AWS.
And for CI/CD, is there anything that you're using?
Yeah, we are using Jenkins. The version control that we are using is Bitbucket, and Jenkins is the CI tool that we use. And from Jenkins, we deploy it to the cluster. So the overall flow is like developer does a check-in. Jenkins CI does the SEM polling. It is going to build the entire service, the application, and it's going to build the image, push it to the AWS ECR. That's where we are having all the images. So it is going to push it there. We consume all the images from that particular repository, and we deploy it through Jenkins itself to any cluster for dev or queue or other environment for production or whatever it is. So what we did is like we customize the YAML file in such a way that we have all the configurations in there. You just have to go ahead and do the Jenkins job that is going to run for you. For each environment, we have the Jenkins jobs. Again, that is again automated as well. We have all the configurations set in the that we have written in Bash scripting. We have it. We have a separate Bitbucket repository for that. So that is automated as well. If I want to make an application ready, I can bring up a cluster and make an application ready. It's going to take only 1.5 hours or 2 hours, because even the cluster creation I've automated it through KOps. Cluster automation upgrade, cluster creation, upgrade, deletion, everything is automated through Jenkins job. So that's what we have done. And the Bash scripting, it's going to for both the applications that we are using, we have application A and B. So for both, we have done the automation through Bash scripting. So it's going to deploy all the services. It's going to be the first time or based on the developer check-in through CI. That's how our architecture is. And Sumo Logic and Wavefront, as I told you, Sumo Logic is for log monitoring, and Wavefront is for the resource monitoring.
So prior to that, Kubernetes, you were using what?
Actually, yeah, I think I don't know, because I didn't join by that time. I think this was fresh application which was done through Kubernetes and microservices. I think the application B is definitely a microservice architecture that was done from scratch. That is for sure. But application A, I don't know, because that is from different team. Application B is our application. We expose the API to, I think, to commercial team and other teams. They consume our services, microservices that we have developed. So application A, I don't know, because they are working from Sweden. I don't know what technology that they were using prior to Kubernetes.
Your services are exposed as an load balancer or
Load balancers.
Not even node pool.
Load balancers. Any other questions regarding Kubernetes or?
What will be the third part of the series?
I don't know. I think we'll have to come up with specific use cases and explain. Maybe cluster orchestration. That is something that everybody are trying to explore and use it. That's one of the cool features that Kubernetes. We'll have to think about it. I think if we are using Google Cloud, then it's going to work out of the box because it's Google application, right? So it's going to work out of the box, unlike AWS.
GKE, it will work out of the box.
Yeah.
That is, it will create a cluster for you with the nodes and everything.
Not like that, but you will not have as many issues that you face when you use an AWS or Azure. It's not that it's going to create automatically. You still have to go through all these steps, but it will be hassle-free when compared to AWS or Azure or any other cloud service provider that you have.
Do you also use any part of hybrid cloud?
No, we don't use that. I think that we can do it through Meetup. Answering, maybe we can get it next time.
Sure.
Any other questions? Or?
Stop here. No more questions? Stop here. But what about next meetup?